Having seen the visualization and the rationale behind the two-pointer algorithm, in fact, now we are ready to write the code. Let me just do that here. So I define a function called pair sum, pair sum, say efficient, just to highlight that this is an efficient algorithm. Same arguments again, L and target. So the problem we are solving is still the same. I can just copy and paste this piece of comment from here. So find if two numbers in L add up to a target, but there's a very important catch that look, this list L has to be sorted, right? So I'll just put that comment here so that it's clear. L must be sorted. Remember the algorithm works by defining two pointers. So I'll just do exactly that. So I'll say left is 0, right is equal to len of say L minus 1. So basically the two extremes. In fact, if you think about it, this is also what we did in binary search. But in binary search, the goal was to search at the third location, which was the the middle of these middle of these two. But in here, we are going to look at exactly these two. So there's a difference there. Now I'm going to do this while left is less than right. Now this has to be a strict less than, because the moment left becomes equal to right, we know that we haven't found the pair that we are looking for, and hence the algorithm has to stop. So this has to be a strict less than. I create a test sum which is given by, well, L say left and L right. So that's my the test that I find that okay, this is the sum right now. Let me compare this with the target. So if test is equal to target, well, if this is the case, I just go and return, for example, left and right. So those are my two indices that we are looking for. If I find that, and this is an elif because I want this to happen, like one of the three things to happen. So elif, let's say, of course, I must skip the condition. Elif say test is less than the target. If this happens, well, I will move my left pointer inwards. So I just go and say left equals to left plus 1. And finally, else, which means the situation is test is greater than or equal to target, right? So equal to case has been taken care by the first statement. So the only one that remains is test is greater than the target, right? So think about it. If else, a very nice usage here, right is equal to right minus 1, right? Now once we do this, let the while loop run. If I find that while loop, if we find let's say a target in between, then we return anywhere in between. On the other hand, if left becomes equal to right, the loop terminates. That's the while loop, and hence I can go and return say -1 and -1. Now just to sort of let's say, so I'll run this once and then we will try this code very quickly for some small list. So we have a list over here. Let me just copy this, but mind you, we now need a sorted list, right? So that's an important point. We'll make this list sorted manually, and then we will run this algorithm to see how whether it's working or not, right? So if I do this, I bring this list here, but obviously I must, let's say, manually go and sort this list, right? So I'm going to say 1, say 2, say 3. Now we can have a repeated item. That's okay. Let's just do that. 5, 8, 17, say 18 and 20. So this list is now sorted. 1, 2, 3, 3, 5, 8, 17, 18 and 20. Here pair sum, it has to be pair sum efficient because that's the function we are looking at. So when I now do this, I get 6 and 8. Indeed, 37 is, well, 6 and 8. So that it's found there. Let's say I were to do 22, right? So let's say 22. I know 0 and 8 will do the job. Sorry, 1 and 8 will do the job because 2 plus 20 is 22. So this algorithm is working. If we have seen the visualization, in fact, it's quite nice. Let's try 6. So 6 is notice 3 plus 3, and we should get 0 and okay, so 6 is also happens to be, well, 1 and 5. So just run the algorithm. The first pair that we find is 1 and 5, which is 6. So basically the idea is that this is working, and think about it, we are doing as many comparisons as there are items on the list, and that's where the order of n complexity is happening. However, we will convince ourselves by logging the runtime of this code as the list increases. The size of the list increases. We'll see this in the next video. I hope you found this interesting. Do look at our website www.ybyte.in. We always build projects in a systematic, step-by-step manner so that it becomes clear for everybody. Take care, forever enjoy coding.